on to homework 7 here, and the first sister problem that I want to do is problem 29, which is a sister to problem 30, both on page 90. And this is these two problems both deal with what are known as piecewise defined functions. Here's f of x, and you can see it's got one form. It's linear, in fact, over the closed interval -1 to 2. So from here to here, the graph of this function is a line. And then from over the interval 2 to 3, 2 is an open interval, is open, and 3 is closed. Over that interval, it's a cubic. So if I just took a moment to draw it, just so that we kind of get on the same page here, there's a break in this function at x equals 2. And as I said, on this side, at least over the interval from -1 to 2, it's defined as 2x minus 4. So 2x minus 4 is a line that has a slope of 2 and an and a y-intercept, of -4. And in fact, you note that when x is equal to 2, 2 times 2 is 4 minus 4 is 0. So this is the graph of this combined function, or this piecewise function, over this interval. Looks like this. This point is the point. If I put in -1 here, I get -2. It's -6. It's -1 and -6. And this point is the point 2, 0. Right? Now, if I do the same thing for the remainder of the overall domain, the domain is from -1 to 3. So I'm looking at this area right here. I'm just going to plot the points for a second. If I put in 2, I get 2 cubed is 8 minus 1 is 6. So at 2, this function would have a value of 6, and I'm just going to write that here. But notice it's an open interval. All right, so I'm going to indicate that in this manner, and I'm going to say that this point is the point 2, 6. I hope I did that right. 2, it is. And from that point on, between 2 now and 3, the function is cubic. And I'm just going to represent this in a quick way. I'm going to put a 3 in and get out 27 minus 2 is 25. So the function shoots up pretty rapidly here up to the point 3, 25. And that point is on the curve. So that's what it looks like. These are sometimes called piecewise continuous functions when these two values are the same. Piecewise defined when they're not, and in fact this function has this major so-called jump discontinuity in it. But nonetheless, it's defined from -1 to 2 in this manner. It's defined from 2 to 3 in this manner. And so if you want to find f of 0, all you have to do is say, well, 0 is over here between -1 and 2. So you just have to put 0 into this function, which is appropriate for the domain -1 to 2, and therefore appropriate for the value 0. If I put in 0, I get out -4. I'm going to do the same thing with 1. 1 is also in this branch of the function, if you will. You put in 1, you get 2, -4, you get -2. If you put in 2, so 2 is on the dividing line, but it's not defined. 2 is not defined because it's really not part of the domain of this second branch. It is part of the domain in this case, so I put in 2. 2 times 2 minus 4 is 0. And then I finish up, if I'm looking for f of 3, f of 3 is appropriate for this domain, which goes from 2 to 3. I put in 3. I get 3 times 3 times 3. 27 minus 2 is 25. And I believe that's what problem 29 wanted us to do. I'm checking, and sure enough, we're done.